Sir, can I ask questions about the assignment before we start?
Assignment 2 or assignment 1?
2.
Um,
I'm not gonna ask about the solutions, just specific.
no, I know. I'm just trying to think if it's better now or at the end.
Okay.
Yeah, you can ask now. Yeah.
Okay. So firstly, for number 3, we're supposed to produce NFAs and then convert them to DFAs. As I was writing them, as I was making my finite state machine, it just turned out that naturally it was logically it was a DFA. Yeah. So is that a problem, or do I have to force it to be an NFA and then convert it? Because especially for the last one, like it's very counterintuitive for me to make it an NFA. Like it was just automatically a.
Isn't it? Is it really counterintuitive?
Well, let me. Or either.
I don't know. I feel like it's a bit easier. I'm not going to say anything about it specifically, but it might be easier to do an NFA. But to answer your specific question, I think it's okay because it says first. Yeah, so I would personally say it's fine if you just give the DFA, but you might need to confirm with the professor, yeah, because the question does say convert, right? So it's explicit in the fact that it wants you to convert. But if he says it's fine, then you'll know.
Okay.
But I think it should be okay.
Yeah. Okay. All right. And then,
sir?
Yeah.
You can continue.
Oh, right. For number 2, is there necessarily like, could it be a trick question, or is there necessarily an answer for both cases? Like an example for which it holds and an example for which it does not hold? If you can answer that.
If you don't think that there's an example, then you have to show why.
Okay, but it's a possibility.
If you don't think there's an example, you have to show why. I can't answer.
Okay, that's fine.
Yeah,
that's fine. Thank you.
Sir,
yeah.
Quick question. Yeah. It's really quick question. So like, I'm just wondering the term that it accepts all strings which has a single B at the end. Does it mean that it accepts BBB? It is not, right?
You're not talking about the assignment, right?
Yeah, like in
just
general.
In general.
Yeah, like it's for assignment 1.
Yeah.
But like, yeah, it's assignment 1A. Then like it's the DFA which only accept it is NFA which only accepts the B at the end, like no matter how many A in front. So like I wrote it like it accepts all strings which has a single B at the end, and I had a comment that it accepts. Then you mean it accepts BBB?
Did I mark it, or
like there's no marker? That's why.
Okay, so I think for that we can talk at the end.
Oh, okay. So like, can you just tell me the general like?
Because I'd have to really read what you wrote. I can't just like it won't come to me really quickly if I just hear you say it. But we can look at it. We can look at it after.
Okay. Okay. Thank you.
So okay. All right. Okay. So tutorial 5. So hello everyone. So like I said, if there are any other questions about the assignment, we can take them at the end. And also, since someone asked, the marking for assignment 1 is almost done. The other TA marked the first half of the assignments, and I marked the second half, and I'm almost done. So that's for that. Okay, the actual course material. So for this tutorial, we'll be looking at regular expressions. So what is a regular expression? So let's look at a very formal definition first. So we're given an alphabet sigma, so your standard AB could apply here. And we define a regular expression as the following. So we're given these two concepts. We're given the concept of a primitive regular expression, which can either be the empty set as a regular expression, lambda as a regular expression, and just a symbol as a regular expression. So we have these building blocks to create regular expressions. And then we have operations that we can use on these building blocks, which are the sort of logical OR, the concatenation, the star operation, and the bracket, even though this isn't really an operation, but it's just to make things a bit neater. So if we're given these two concepts, then a string S is a regular expression if and only if it can be obtained from the repeated application of operations in 2 on the building blocks or on the primitive regular expressions in 1. So what the heck does that mean? It just means that the individual or the sort of atomic elements of your regular expression have to be either the empty set, lambda, or symbols, and then you can build up regular expressions by using operations. So for example, here, I have A logical or lambda concatenate with BA or empty set star. So this is a valid regular expression because we're using these primitive regular expressions and building them up with concatenation, logical ORs, and star operations. So that's what we have for our first example here, which is a valid regular expression. Then we have an example of a regular expression which is not valid, so something that actually isn't a regular expression. And so this often happens when students mix up the regular expression notation with the set notation. So even in the assignments, I saw something like A star B and B A star, something like this, right? So this is neither correct set notation nor correct regular expression notation. This is you're trying to mix regular expressions with set operations. That's not something that you can do. So this operation here is for a regular expression. This operation here is for a language or a set, and so you can't mix the operations. So even though, and so I know someone's going to ask the question, even though the star operation looks a lot like the clean star operation, the clean star operation is for languages, and this star operation is for regular expressions. Okay, so you have to make sure you see that kind of difference. Okay, but the actual use of a regular expression is that it allows you to give a very compact way of representing what a language contains. Okay, so if we're given a regular expression R, then L of R, much like L of M, where M is an, where M is an FA, L of R is the language denoted by or represented by the regular expression R. So it's much like how L of M, where M is an FA, L of M is the language accepted by an FA. In this case, a regular expression denotes or represents a language. Okay, so if you have a regular expression, what do you do to find the language that's represented by it? Well, you use a combination of operations. You use these operations on primitive expressions. So L of the empty set is the empty set, L of lambda is the language containing lambda, L of a symbol is the language of that symbol, okay? So these are for the primitive regular expressions, how do language operators apply to those? And then for operations, the operations have a one-to-one correspondence with language operations. So the logical OR, when you have L of R1 or R2, that corresponds to a union for sets. The concatenation for regular expressions corresponds to the concatenation for languages, and the star operation for a regular expression corresponds to the clean star operation for a language. So there is they look similar, and so they look similar, but this is, of course, the clean star operation on the language, and this is on the actual regular expression. And what this does is it gives us a dictionary, gives us a way of translating one notation to the other, okay? So with that being said, how can we, given a regular expression, actually decipher what the language denoted by that regular expression is? So we're going to look at an example for that. So the first example here is I have my regular expression R, which is A or BB, concat AB star. So what is the language denoted by R, by this regular expression? So I'm just going to walk you through these operations step by step, and then we're going to do some exercises. So L of that regular expression, how can you decompose this? Well, we first noticed that there's a concatenation between regular expressions. So we can say that the concatenation of regular expressions is converted to the concatenation of the languages that it represents. So that's why we convert this to two separate languages which are concatenated together. Then we translate the or the logical OR operator to a union here. And here we take the star that's applied to the regular expression and now take it out and apply it to the actual language, okay? Then we use kind of two rules at the same time. So L of BB, actually what's going on is you're decomposing it even more into LB, LB, and L of B, remember from where's the rule? From this rule, sorry, from this rule. So L of a symbol is the set containing that symbol, so it's B and B. So then that'll give you B, B. Okay, but we don't usually write that process. We just sort of immediately write it out. So that's why it's immediately written out here. So then we have the set A union the set BB, or the languages. So then the union operation, we just take the elements from both and put them together in the language. So that's why here we get A comma BB. And here we're just applying the star operation. So then you could actually, I would be fine if you, so this is okay. It's okay to stop here, in my opinion, but if you wanted to write it out even more, then you could say, oh, this is equal to A concatenated n number of times AB, union BB concatenated n number of times AB. Okay, but both of these would be fine in an assignment or just in general kind of language notation. All right, so that's an example. Now an exercise which I'm going to let you do. So given the regular expression here, how many strings of length 3 or less are there? So I'll give you a minute while I go get a drink of water. Okay, so 1 minute. All right, so let's look at the solution. So we're given this regular expression, and we want to know how many strings of length 3 or less there are in the language denoted by the regular expression. So we start off with writing L of R. So what is L of R? It's L of 0 or 0, 1, 1 or 1, 1 star. Okay, so I'm going to skip a few steps just because I know you've seen this already in lecture and they're pretty sort of intuitive. So here I have the concatenation of regular expressions. So I'm going to concatenate the languages they represent. And I'm also going to take the star operation out here. Okay. Then I can just convert L of 0 or 0, 1 into the set 0 or 0, 1. And I can do the same thing here, applying the star operation. And what I can actually do to even further simplify, because this would probably be enough to let you get those strings of length 3 or less. But what you can notice actually is that this language is actually equal to 1 star. Okay, because anything that can be produced by any number of pairs of ones can be produced by any number of single ones, right? Because you just have to double the number of ones, right? So these two languages are equivalent. They contain the same strings. So then I could rewrite this as 0 or 0, 1, 1 star. And then I can list out some of the first strings in this language. So lambda 1, 1, 1. And I'm not going to do more because I know I'm going to concatenate a string of length greater or equal to 1 with a string of length here at most 2. So I'm not going to go 3 because then I would get 4 symbols in my string, and I'm only looking for strings of length 3 or less. So that's a trick just in general for time management, is don't try to expand the language more than you need to if you're doing a problem like this. So then what do you get? Well, you can take 0 and concatenate it with each of these elements. So you get 0, 0, 1, 0, 1, 1. And doing the same thing with 0, 1 is actually just going to give you duplicates, because 0, 1 lambda is going to be 0, 1, and 0, 1, 1 is going to be 0, 1, 1. Right, so and so on. And so these are going to be the only 3 strings of length 3 or less. So the question was how many, and so there are 3, and they are these strings. Okay, so I feel like that was pretty straightforward, but if there are questions about that, let me know. If not, let's look at the next question. What is the shortest string in this language here? So this one, let's do it together, just straight off the bat. So we do have sort of 2 languages which are intersected. I'm going to start off with by expanding this one, and then with the intersection of the other one, seeing what the common elements are. So I have L of these 3 regular expressions which are ORed, and I see that there's a star operation, so I can just take the star operation out, and at the same time, let's also use the union. So we'll use the union here, or L, or sorry, whoops, L of the empty set star, and then I can once again, so here it is a concatenation of regular expressions. So I can do the concatenation of languages. Here it's L of A plus lambda, or A or lambda. And so I know that L of A or lambda is just going to be the language A comma lambda. And it's going to be concatenated with L of the empty set star, which, so this will give you the empty set star, And I hope that you remember that the empty set star gives you the language containing lambda, right? So that's for that portion. Then union B, union L of the empty set is the empty set star. Okay, so then what do we have? We have A comma lambda concatenated with lambda. That would just be A comma lambda. Union B, union the empty set. So anything star, sorry, don't forget to carry the star. So anything union the empty set gives you that anything. So here, actually what I get is A comma B comma lambda star. Okay, so this looks a lot like A comma B star. And in fact, these two things are equal, right? So what I've just found out is that this language actually gives me the universe. So really, it means that I have sigma star. If sigma is AB, I have sigma star intersect L of A, B, A star. And so the universe intersects something, gives you that something, right? So gives you L of A, B, A star, right? And then this will give me A concat B, A star. And if I'm looking for the shortest string is going to result by looking at lambda for this language and concatenating with A here, and thus giving me A. So this is the shortest string. Okay, so I hope that's clear. Again, if it's not, just let me know. I feel like, yes.
I have a quick question. When we're asked to find the shortest string, I mean, from this example, I assume that lambda doesn't count. Like we don't consider lambda as the shortest string for an accepted language, an accepted string in the language.
Why do you say that? Isn't lambda is a string, right? It's the empty string.
Okay, so if the shortest string accepted is lambda, that's the end. Okay.
Yeah, so if the shortest string in the language is, if lambda is in a language, right, then the shortest string must be lambda.
Okay, all right. Okay.
Good, okay.
I have a question.
Yes.
In this example in your notes, the final answer is AB star or A?
The final answer for what is the shortest string is A.
Is A, okay.
The final answer for, yeah. No, it's
Okay.
fine.
Sorry, I didn't read the question, I'm sorry.
Oh, no, don't worry about it. Don't worry about it. Yeah, okay. Okay, good. So now that we've looked at sort of, so what we've looked at so far is, for the last two examples, is regular expression to language. So now we obviously have to do the harder version, which is if you start with a language, how do you describe it with a regular expression? Okay. So let's look at that together. Now, we want, the first language that we want to write regular expression for is the language over 01, right, over the alphabet 01, such that all the strings in that language contain 101 as a substring. Okay, so this one, and in general, substrings are actually quite easy to actually write in regular expressions once you know the trick. So the idea here is you're kind of using a regular expression as a pattern matching. So imagine you have a string W, and so W is a bunch of symbols, right? It's a bunch of zeros, ones, zeros, blah, 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 until let's say 1. Really what your regular expression is trying to do is it's trying to match a particular sort of sequence where it can find 101. So you know that in your regular expression, you're going to have to have 101, right? Because you're going to match, you have to match 101 in your string. it has to be in your string. Otherwise, it doesn't belong in your language, right? So I know that my regular expression, when it's going to kind of look for this pattern, it's sort of going to want to look for 101, right? So I know that 101 has to be in my pattern of my string. And of course, because it's a substring, just like in DFAs and NFAs, I don't care what's before the substring or what's after the substring. So before it can be literally anything, and after it can also be anything, right? And so what is anything for our purposes? For our purposes, it has to be the kind of universal set, but represented by a regular expression. And what's the easiest way to represent a regular expression? What's the easiest way to represent the universal set through a regular expression? It's by writing all the symbols in the alphabet. So in this case, 0, 1, putting the logical order between them and applying the star operation, right? And so I do this before and after my substring, okay? So what does this tell me? This tells me that I can see anything. So I can see a 0 or a 1 any number of times, as long as at some point I see 101, and after that I see anything else. Okay, so it's very similar to how you would write an FA for this. So if you wanted to write an NFA for this, then you could just say, okay, so I have 0, 1. I can look for 0, 1 any number of times. And then when I see 1, 0, 1, then immediately I can accept anything. And so I don't care what's after. Okay. So, and you can kind of see that there's a one-to-one mapping or correspondence between a regular expression and an FA. And that's actually going to be the discussion at the end of the tutorial. But that's how you would write this type of regular expression. Okay. So for substrings in general, this is the kind of idea. Next, we have another one, which is for languages over the alphabet 0, 1, where the strings have an even length. Okay, so if you look at a string that has an even or an odd length, when you're trying to see if it has an odd length or an even length, what are you doing? You're just looking at pairs of symbols, right? So if you have pairs of symbols and you have a perfect number of pairs of symbols, so an integer number, then that string has an even length. Otherwise, it has an odd length. And so that's the idea behind the pattern that you're going to look for. It's essentially going to be the fact of having any number of pairs, right? So that's what your string would look like. It's any number of pairs of zeros and ones, right? So for instance, here, I could have a 0 or a 1. So let's say it's a 0. And then here, I could have a 0 or a 1. So let's say it's a 1. And then I would have this pattern any number of times, right? And then that becomes the regular expression for this language that denotes this language, okay? And so if it was, let's say mod, if instead of even, it was mod 3, then you could say you were looking for triples, right? So you're looking for 0, 1, 0, 1, 0, 1, and then any number of times, okay? And that's how you would tackle, in general, any kind of modular or kind of cyclic length sort of language. That's how you would write a regular expression for it in principle. Okay.
Sir, would you
Yes.
be allowed to do something like 0 or 1 to the power of 2i, for example, where I is
No.
greater? No, it's not programming.
No, that's a good question, but no, you can't. I know why you're asking me that though. Because if you had maybe, let's think of if you had something like, if you always want to match something that looks like any number of zeros, let's say to the 7. Okay, so 7 numbers of consecutive zeros, and then let's say 5 numbers of, like, that doesn't have to actually, it shouldn't be the same. So let's say you wanted this language, right? Then what you can do really is this 7, actually, it just, you can just sort of expand it down to say, to sort of hard code 7 zeros, right? So you have 7 zeros, and then you can have those 7 zeros any number of times. And then the same thing for the ones, right? You can have 5 ones, and you can have those any number of times. So that's one way of sort of hard coding this, the fact that it would be the same, right, if it was 3, right? If it was 3, you could do the same thing. And so actually, this is really doing the same thing as well, because if you have 0 or 1 and 0 or 1, this is equivalent to 0, 0 or 0, 1 or 1, 0 or 1, 1. And so you're listing all the possible pairs, and you would do the same thing if it was just, let's say, 0 to the 2i. Then you just say, okay, it's 0, 0 star. But here in this case, it's because it's any even string, it doesn't matter if it's 0 or 1, then it's any pair of zeros or ones, and then star. But no, you can't be lazy basically, and you can't write 0 or 1, 7 star. Yeah, please don't do this in your time. Okay. So yeah.
Okay, thank you.
Okay, no problem. Okay, so that's for this type of regular expression. Then I think we have a last one. Yeah, okay. So actually, oh, this one's pretty similar to your assignments. Okay. Okay. So so in this in this language, so what does the language look like? It's any string where the sort of the first 2 symbols of the string are equal to the, or are the same as the last 2 symbols of your string, and you have anything in between. Okay, so what does that look like in terms of a regular expression? Well, in this case, you don't have a choice. You really need to sort of hard code, quote unquote, the V here, right? Because you know that in your pattern, you have to recognize the same symbol at the beginning as at the end, right? So what does that mean? That means that you would have, what are the possible pairs, right? Because here, the length of V is 2, so I need to list all the possible pairs. So it's either I have AA at the beginning and AA at the end, or I have AB at the beginning and AB at the end, or I have BA at the beginning and BA at the end, or I have BB at the beginning and BB at the end. And in between, right, in the middle, I don't care, right? It could be anything. So it could be A or B any number of times, right? And I'm going to write the same thing here and here and here. Okay. And so this would be the regular expression that would denote this language. Okay. So yeah, I'm not going to say anything else about this, but you can kind of see how this is a lot easier than maybe writing, hard coding a DFA potentially, because this is a lot quicker for the regular expression sort of writing, and it's pretty easy because of how these operations work and how they relate to languages. Okay, so so that's for that exercise. If there are no questions, I'll go to the next one. oh yeah, there's an, okay. So this is, I'll let you do these two because they're interesting. So we have a different type of concept which applies to regular expressions, which is the idea of equivalent regular expressions. So what are equivalent regular expressions? So suppose you have two regular expressions, R1 and R2. Then we say that they are equivalent, and so we use this symbol if and only if the languages that they represent are identical. So for instance here, is it true that these two, no, this should be, is this true, right? Is it true that the regular expression on the left is equal to the regular expression on the right? Well, in this case, it is, and you can prove that using the operations, so the kind of atomic operations. So I won't write it out, actually, I'll just follow what I have written here. So L of R or the empty set star lambda. So I can use the concatenation principle here to map my regular expression concatenation to language concatenation. So here, then I have L of R or empty set star, so I can take the star out. Then the or becomes a union, and I still have the star outside. Then remember that if I have the set A union the empty set, then that'll just give me A. So that's what I'm going to apply here. And the other thing I'm going to apply is L of lambda is, L of lambda is equal to the language containing lambda. And I know that A concat the language containing lambda is A. And so I just have to write L of R star. And then I can just, to make the two regular expressions equivalent, I can bring my star back in. So now I have R star. Now let's say this is R2 and this regular expression R1. Because their languages are identical, the regular expressions are indeed equivalent. Okay. So these are very nice questions because they're nice to ask true or false questions about. So here's an exercise. I'll give you a minute for both of them, and then we'll look at them together. So let's say 54 and a half. All right, so we have these two regular expressions. We want to know, there should be an extra bar here. So for the first one, let's see if, what do you guys think? Do we think they're equivalent? Not equivalent, okay. Okay, so I agree. Why do I agree? Well, the best way to do these types of questions is just picking regular expressions that are very primitive. So picking the primitive regular expressions and then seeing if you apply L of both sides, will you get the same language? So I can do that here for the first one. So if R1 is A and R2 is B, then on the left-hand side, I have A or B star. And I know that L of this is the universal set. And on the right, if I have L of A star or B star, well, I know that this is going to give me A star union B star. And hopefully everyone sees that these two are definitely not equal. This is the set of strings where it's any number of A's or any number of B's. And this is the set of all possible strings, right? So clearly very different sets of strings. So the second, yes?
I have a question. So
Yes.
to disprove this, so we just need to find the counter
Example. Yep. And to prove it, you have to do this method. So you need to show that L of R1 is equal to L of R2.
Okay.
C'est bon? Okay. The second one. So is the second one, do we have an equivalence there? Oh, that's a good question. No, I mean, for me, this would be enough. This is usually enough. This is enough to be a counterexample. If you want to convince yourself even more, then you can use a specific string to show, but then you're using the specific string to show that the languages aren't equal. And so that's you don't really need to go through that step if you can clearly see that they're not equal, right? But that could be an extra step just to sort of validate your thinking. So because, for example, here, your example, Jonathan, ABBA, so ABBA is in here, but it's not in here. And then because you have an element which is on the left and that same element is not on the right, clearly the two can't be equal. Okay. So the second one, someone says that they don't think it's equivalent, and I'm going to agree. So why do I agree? I'm going to pick the same exact example. Let's say R1 is A, R2 is B. And on the left, I have AB star. And on the right, I have A star, B star. And if I do L of both sides, then this is going to be the language ABN, for n greater or equal to 0. And L of A star, B star here is going to be AN, BM for n comma m greater or equal to 0. So these are clearly different, right? This is any number of consecutive ABs, and this is any number of consecutive A's followed by consecutive Bs. Okay. Yes, very good. So maybe. Yeah, so that's for these types of examples. I'll leave a question for you to try. And I'm going to give you a specific example. So if I have A or B star, which I know denotes the universe, is this equivalent to A star, B star, star? Okay. So that's my question for you. If so, try it, and if it doesn't seem like it, or if you're stuck, let me know, and I'll be happy to help out. All right. So so that was for equivalencies between regular expressions. The next topic is how do you sort of yeah, so that's the next topic. The next topic is, so we did regular expressions to languages, and we did languages to regular expressions. And we also know how to go from an FA to a language and how to go from a language to an FA. So clearly there's an indirect path. There's an indirect path to go here and to go here. But is there kind of a direct way of doing it? Okay, and so the answer is yes, thankfully. And so the first one that I'm going to show you is, if we're given a regular expression, how can we sort of easily go from that to an FA? So to do that, we're going to look at, yeah, so I don't find that these steps, it's not going to be relevant for me to just read them. So I'm actually going to go straight to an example. Okay, and actually straight to this. Okay, so the idea is really to map very much like how you mapped the operations of regular expressions to languages, to do the same thing for regular expressions to FAs. So for instance, if you have a regular expression R1 or R2, then the idea is you're going to have a machine M1 such that L of M1 is equal to L of R1. So you're going to have this machine M1, and you're going to have the same thing for M2. And to do this kind of union, what you're going to use is you're going to use lambda connections, right? So you're just going to take a lambda connection to M1 and take another lambda connection to M2, okay? And this allows you to sort of convert this regular expression to this corresponding FA, okay? And then the same thing for the concatenation. So let's say you have R1, R2, and you have the corresponding FAs M1, M2. Then to join these two together, you just take, here we're going to assume, so assuming one final state, which it's always possible to have a single final state in an NFA because you can just take all the final states, connect them with lambda transitions to a single mega final state, and then make these guys non-final. So I'm assuming that this machine and this machine have one final state. You're allowed to make that assumption. Then I can take the final state of this guy, lambda connect with the initial state of this guy, and it'll finish in the final state here of this guy. Okay, so that's how you would convert the concatenation of regular expressions to the concatenation of an FA. So this is one operation, this is a second operation, and the last one is R1 star. So R1 star is essentially you can match R1 any number of times, including 0. So you have the machine that accepts the strings that are denoted by R1. So you need that as your building block, right? Then once you've kind of accepted the first run of that string. So let's say you have a string which is 3 R1s in a row. So you finish here, so you finish reading the first R1, then you can use a lambda connection to start over and go through the sort of a machine again for the second R1 and then for the third R1, and you finish off at your final state. Or if you just have a lambda, and you can skip the machine and go to the final state immediately with a lambda connection as well. So this is how you convert that operation. And so with this, you're basically able to do everything you want. You're basically able to convert any regular expression. Doesn't matter how complicated it is. So you can go from here, from this regular expression to this regular expression, and just keep the rules going, stacking the rules to get your final FA. So that's what we're going to do here as an example. So I have the language L of AB star AA or B BA star, right? So this is like R1 or R2. So this is going to be the machine for R1, so let's say M1, and this is going to be the machine for R2, let's say M2. So I'm connecting the initial state with both of these through lambda connections, right? So through this lambda connection and this lambda connection, and then I'm finishing with a final state with these two lambda connections. That's annoying. Okay, so that's for the OR. Then inside I have some concatenations of A, B star AA. So just to keep it short, we're not going to just do right? We're not crazy. We're not going to do A lambda B, because yes, this is fine. It's the same thing as AB, right? It's the same thing as AB, but just to save time, right, and to save space, typically this is the one that you're going to write, or at least the one that I hope you're going to write, because it's a lot easier to read. So that's what we're going to do, right? We're going to take this this A and then concatenate it with here. Instead of doing this trick here with the lambda connections to and from the empty initial, the final initial state. In this case, I can just use a single state and a loop with B because it's a single symbol. So this corresponds to B star, right? And then I can concatenate that with A and A, okay? So that's how you get this piece of the puzzle. And then for this piece, I have B. This lambda connection isn't that necessary. It could have just been, you could have just done, you could have just done a big B here. But we wanted to keep it a bit rigorous, so that's why we put a lambda there. And then here, this is where the BA star happens. So like I said, you can go through BA once, right? And then when you get to the end, you can use this lambda connection to go again through BA and then use it any number of times, right? Or if BA star isn't matched at all, then you can skip it with a lambda connection to go here and then end up in the final state. So that's how you would convert this regular expression to this FA. And yes, of course, you are allowed to make this simpler. There's no need to sort of, as long as you're comfortable with the conversion, then you can make it simpler. But if you want to just, if you're doing your first example, or like if you're maybe unsure of how to start, then you can use these rules as the building blocks. But yeah, it's totally fine if you just straight away want to go with a simpler version.
I have a question.
Yes.
In your M2, why do you have 2 lambda back to back after the B? You have double lambda.
Yeah, that's not. Yeah, that's a good question. It's not really useful actually to have a lambda here.
Okay, that's fine. That's fine.
I think maybe the reasoning behind, because I don't think I wrote this. Yeah, I didn't make this one. The solution for this one is that this is the machine for B, and then this is the machine for BA star, and so you can use a lambda to connect them. But of course, you can just, right? I mean, we both know that we don't need that, and we could just sort of directly connect them. So yeah. So by all means, if you want to make it simpler, it's totally okay. Okay. So all right. So how are we doing on time? Okay, it's because I wanted to introduce the next, but this one's going to take time to explain. Okay, so I think I won't do this part because it'll take too long to explain. But it might be useful for the assignment, so I think I might post a recording. Yeah, so I think that's what I'll do. Unless you really want me to do it like during the tutorial, but otherwise I'll just post a recording if that's okay. Because we also want to cover grammars next tutorial, so that you can have everything you need for the midterm, which is on Saturday. So that's the reasoning why I think I'll just do a recording for this section. Okay, so well then, because it's the last exercise, let me actually give you a chance to do this one on your own. So I'll give you maybe a minute, and then we'll look at it together. Okay, so it seems like people don't mind the recording, so that's cool. I'll post it. I'll post it tonight. All right, so take a minute and we'll look at it together. All right, so hopefully you had the chance to look the exercise. So, oh, where did I put my pen? Oh, okay. So we want to find an NFA that accepts the following language. So how are we going to do that? Well, we're basically just going to use the same kind of idea as I showed in the example. So split the machines by components of your regular expression, and then sort of merge them together. Oh, interesting. Okay, I guess. Okay, the comment there, opening up ABD star is Morgan's. So that might be another way. I feel like that's what you're saying. I don't know if what you're saying is you take the union and you see what the result of the union is. So that's maybe one way. But that I feel like that would be maybe it'd be a bit easier to make a mistake that way. I feel like lambdas, it's a lot easier to just do it kind of straight away. So let's say I start here with my initial state, then I do a lambda connection to do two different types of machines. So for AB star, let me do that. So I'll say it's A, B, B, right? So that's one pass. Then I could go back to ABB again, or I could simply just skip it, right? And then for the other one, A star, B, B star. So like I said before, A star, I can just use a self loop on A, then B, and then a self loop on B, and that's it, right? So then this isn't necessary, like you're not obligated to do this, but if you wanted a single final state, then what you could do is just lambda connect these guys together. And maybe one of the advantages, I would say, of this method is that it's very like modular. So it's pretty easy to work things around even if you modify the regular expression. So let's say I just added a star here, and then the idea of doing the union, that would be, well, in this case, the union would actually just be, it would probably just be this guy. So it might work in your favor in that case, but you could also just say, okay, well, let me just add a lambda here so that I can skip through the A star BB star, or I can go back with the lambda back to the A star BB star. Okay. And then if you want it to be like super rigorous, then you might have wanted to add like an extra state here, like a lambda here, and then a lambda here, and then said something like this. So this would be the same thing, right? But if you want it to be like super rigorous and respect that kind of modularity with the stars, with the fact that you can sort of build chunks together, right? With this with these lambda connections. So that would be another way of easily modifying the FA so that it reflects this change in the language. Okay. So so in general, that's how you would do these. And in general, it's also fine if you simplify them. So yeah. So maybe one last comment before I let you go is what we've shown basically is that with this method here, with this kind of algorithm, is that for every regular expression R, there exists an FAM such that L of R, so the language denoted by R, is equal to the language accepted by M, right? So it means that every regular expression has at least one FA that's going to accept the language that it denotes, okay? So actually this shouldn't, okay, this should be after this, but what we're going to show in this section is actually the other way, is that for every FAM, right, so every finite automaton M, there exists a regular expression R such that L of M is equal to L of R, okay? And so if we know this, if we know 1, and we know 2, right? So what does that mean? That means that there exists an FAM such that L of M is equal to L of R if and only if there exists a regular expression R such that, and then the same thing, okay? And because of this bidirectionality, it means that to show or to prove that L is regular, we already saw 3 ways, right? The first way was with DFAs, the second way was with NFAs, and the third way was with, well, basically using 1 and 2 and then using closure properties. But now we have a fourth way, we have another way, which is using regular expressions. And of course, closure properties are like, they apply to languages. So you can only use closure properties to languages you already know are regular. So really the main ways that we've actually seen are DFAs, NFAs, and regular expressions now. And with the fact that now you can prove that smaller languages are regular, then you can use closure properties to manipulate them to then show that larger languages are regular. Okay, but basically this is just going to be an algorithm that's going to be quite straightforward to show you. Well, it might not look straightforward, but it will be when you look at the video of how to do sort of a step-by-step conversion so that you'll never need to really think again of how to convert an FA to a regular expression. It'll just be very kind of sequential. Okay, so yeah, so that's it for in terms of content for the tutorial. Now I'm open to questions about assignment 1 or 2 or anything else.
Hello?
Yes.
Hey, sorry. I have a quick question about about this assignment that's due in 2 days.
Mm-hmm.
So, you said it might be okay for question 3 because it does say to explicitly
Let's say that, yeah.
convert, right? So like, for example, for one of the three, what I did is I just added like a bogus lambda connection to make it an NFA, and then converted it to a DFA. Would that be okay, or it does have to be like a legitimate NFA?
So there's no such thing as a legitimate NFA. So I
Yeah.
mean, like it says it says convert, right? It doesn't say in what way to convert.
Okay.
So yeah, I think that should be okay.
Okay. Sounds good. Thanks.
No problem.
Hello, okay, can you hear me?
Yes.
In the assignment one solutions, I was looking them over and it says
Yes.
that for the first question, the third
Yes.
FA,
Yes, that's a
Is it-
mistake. Yeah.
oh, it's supposed to be a DFA.
Yes. Yes.
Oh my God, okay, thank you.
Yeah, don't worry. We marked it. We marked it knowing that it was a DFA.
All right, thank you very much.
No problem. And actually, maybe a general comment on assignment one is from what I've seen so far, it's been actually quite good. Maybe there wasn't really anything that shocked me. It seemed like a lot of you understood the material from what I saw in your assignment solutions. There might be there was a few like very common mistakes that I saw. Like for instance, do I have assignment one? Yeah. Oh, I'm not showing it though. Okay, I'm gonna change the screen I'm sharing. Okay. Oh God. Okay, stop share. Share screen. Share. Okay. So yeah. So yeah. So the first question that was it was in general was well done. Yeah. So I think everyone got the question. Is it an NFA or a DFA? So very happy. No. So in general, this question was fine. Yeah, no, and honestly, I was actually quite surprised. You guys did a really good job on the assignment questions. There's nothing that really sort of came out in terms of something that had to be kind of corrected that was very urgent to correct. In general, it seemed like the material was well understood, so I'm happy about that. Can you give us an update? Let's say I can't make any promises, but like probably let me think. So I can probably maybe tomorrow or Wednesday, I think, which I feel is fair, right? You submitted it on when you submitted it last Wednesday.
Yeah,
So,
I'm sorry. I'm the one who asked that question also, just
Yeah.
because the semester moves really fast because this is like a
Yeah.
half semester, but I didn't want to like force you into doing any grades. I was just curious.
No. I understand. No, I also agree that, I mean, it's annoying when, the assignment one mark comes out at like the end of the summer semester. It's like, it doesn't make any sense. So for sure, I think, because I mean, we're basically almost done, right? So then it's just a matter of checking with the professor if the average is okay, and then posting it. So I think tomorrow or Wednesday should be realistic. But it's fair to ask. I think it's a fair question. So any other questions about assignment, any of the assignments or the quizzes or something? Or
Yeah, I have one more actually.
yeah,
How strict are you guys gonna be on like grading our DFAs and NFAs? Like if there's like
that's a good question.
yeah, because there could be some different solutions, right? to like the
Yeah.
same question?
So in my case, if the NFA is like if it accepts the language,
Okay.
if it accepts the right language, then you always get full marks.
Okay.
So it's not a question of like, oh, it's different from the solution.
Mhm.
And then depending on, so then in the case where, you know, there's a mistake, then if it's a very small mistake, then I don't usually take off a lot.
Okay.
But then if it's something like it accepts, like let's say, I don't know, I can't really think of an example, but let's say the question was you had to do something mod 3, and then in your answer it's, you know, something like this.
Mhm.
So I you know, I can maybe I can't really give you that many marks. I'm still going to give you some part marks, but I can't give you a lot if the FA's logic is like completely off. You know what I
Got you.
mean?
Yeah, I got you. I got you.
But yeah, there's part marks. To be honest, as long as it's a DFA, if a question asks create a DFA, you'll probably get marks. So
Okay. Cool.
So,
Sounds good. Thanks.
yeah, no problem.
I have one more question.
Yes.
So if you have a state that is transitioning to another state and also to an empty set, what's the correct way to define this set of states? Should we just, let me type it out, wait.
Transition to empty state.
So for example, we have a state that transitions to state Q1 and also to the empty set.
Yeah.
Is there one way that is more correct than the other, or both are fine?
Oh, okay, I see. You mean like the empty set as in like when you do the conversion, right? So like at the end you have like you have the empty set, like the trap state.
Yeah, I'm doing the table for the conversion
Yeah.
from NFA to DFA.
Yeah.
And I just want to know how I should write it. Just
Oh,
Q1
okay.
comma nothing, or Q1 comma the,
No,
I cannot do the symbol here. But, yeah.
Empty set. Yeah, the symbol is good. Don't write nothing because the
So
empty
the
set.
first one is okay. Thank you.
Yeah, because the empty set is not nothing, right? Everyone's shaking their heads. I can tell. Okay. Okay, good questions. I think there was also someone that had a question. I don't know if they're still there. About a particular comment in the marking. I don't think they're still there. No. Okay. Well, I mean, in any case, if you ever have comments about the marking, when it comes out, you can just send us an email, and just send an email to both me and Tianyi, and then depending on who marked the student, we'll answer. So that's for that. For a midterm review, so the tutorial in principle, next tutorial is going to be, because there's still going to be grammars on the midterm, so we're going to cover grammars. I might do an extra, I'll let you know, depending on how busy I am, but I might do an extra tutorial. Probably, if I do one, I'll do one on Friday night for a midterm review. So usually what I do is I do a couple of questions, and then I just take, I just do Q&As. So I do maybe 30 minutes of questions and then Q&As for 30 minutes. So I might do that. No promises because I might be very busy, but I'll let you know. I'll let you know Wednesday probably. Okay. All right. So it doesn't seem like there are more questions. But again, if you ever need anything, just send one of us an email, and we'll be glad to help. All right. So take care, everyone. Have a nice lecture, and I'll see you Wednesday. Bye-bye.